All right, let's dive straight into today's explainer because we are looking at a story that feels way less like a dry scientific report and so much more like a gripping, edge-of-your-seat survival thriller. Imagine an astronaut fighting for their very last breath to stay alive, except we're actually talking about Voyager 2. This is a piece of 1970s technology that is out there right now, still communicating with Earth against absolutely all odds.
Look at that number, 21 billion kilometers. That immense figure represents the vast, freezing void between Earth and this lone little spacecraft. To put that into perspective, sending another probe out to where Voyager 2 is right now would take us decades. I mean, we're talking close to a century of just waiting around. And this vast distance, it highlights exactly why NASA engineers are fighting tooth and nail to keep this specific spacecraft alive for just one more day. Because if we lose it, this amazing window into the deep unknown closes for a very, very long time.
Part 1. Alone in the Dark, the 50-year journey.
Now, to truly understand the stakes here, we have to look back at a mission that has lasted nearly half a century. Voyager launched back in 1977, and get this, it only had an expected lifespan of 5 years. Its primary job was just to explore the giant planets of our outer solar system. It flew past Jupiter, checked out Saturn, and actually became the first and only human-made object to reach the ice giants Uranus and Neptune. It sent back these incredibly clear, beautiful photographs, but after zooming past those planets, there was simply nothing left to photograph. Its visual journey was completely over. But, as you'll see, its true, hidden mission was just getting started.
So the really crucial point here is that after crossing a massive cosmic boundary in 2018, its cameras were permanently shut off. That boundary is known as the heliopause. Think of our sun as a bright star sitting right inside a giant protective bubble created by solar winds. Well, Voyager 2 actually pierced right through the very edge of that bubble and burst out into the true empty space between the stars. With 0 planets left to photograph, its cameras were powered down, completely transforming it into this dark space laboratory. Here's the wild part. Being 50 years old is actually its greatest advantage right now. Why? Because it is literally the only machine out there capable of acting as our remote lab. It's gathering this hyper-specific data from outside our solar system that no massive Earth telescope could ever hope to see. I'm talking about measuring things that are completely invisible to the naked eye, high-energy particles beyond the sun's reach, interstellar magnetic fields, and cosmic plasma waves. It is literally inside that alien environment, experiencing the whole shebang firsthand.
Part 2. The Deadly Power Drain, a War Against Time. Okay, so let's talk about the main crisis. The invisible enemy stalking this spacecraft isn't some external alien threat, right? It's its own decaying heart. Out in the deep, dark space where sunlight just simply doesn't reach, solar panels are completely useless. So instead, Voyager 2 is powered by a nuclear generator running on plutonium-238. This essentially turns the heat from natural radioactive decay into electricity. But because of that natural decay, it is steadily losing about 4 watts of power every single year. Now, early in the mission, losing 4 watts a year was no big deal. But after 5 decades, that tiny natural loss has compounded into a massive, life-threatening energy crisis.
It is just absolutely mind-boggling when you stop and realize that this multi-billion-dollar, history-making mission is currently surviving on less power than the absolute smallest LED light bulb in your house. I mean, to save electricity, NASA engineers have literally been doing everything they can over the years. They ditched non-essential equipment the second the planetary flybys were done, they turned off the onboard heaters, and they have been painstakingly shutting down scientific instruments one by one just to keep the core systems breathing.
But all that intense rationing led right to the 2025 crisis. NASA engineers realized that before the year 2025 was over, they were going to be forced to shut down yet another major scientific instrument. And here's the kicker. Every single time they turn an instrument off, we lose a piece of irreplaceable cosmic data forever. They were totally backed into a corner, completely fresh out of easy options.
Part 3. The high-stakes hack, the Big Bang solution. You know, when backed into a corner, that's usually when human ingenuity really kicks in. The engineers decided, you know what, we're going to stop shutting things down. Instead, they tried this desperate, unprecedented maneuver, a highly risky hack they playfully dubbed the Big Bang. The spacecraft has this voltage safety reserve, which is basically an emergency backup meant to protect the systems from unexpected electrical spikes. The team decided to tap into this safety reserve and reroute that power directly into the science instruments to keep them alive. Just think about the sheer audacity of this for a second. They are altering the fundamental power architecture of 1970s technology from billions of miles away, completely bypassing automatic safety triggers just to keep the science going.
Part 4. A 38-hour wait, holding our breath.
Now, executing this rescue mission wasn't quite as simple as just pushing a button on a keyboard and watching it happen instantly on a screen. It required enduring some truly agonizing suspense. Because radio signals only travel at the speed of light, it still took roughly 19 hours for the command to just physically reach Voyager 2. And then, once the probe actually received it, it took another 19 hours of dead silence back on Earth to hear if the command actually worked. That is a 38-hour round trip just to get a basic status update.
And they couldn't just use any old satellite dish to send the signal either. Because Voyager 2 is traveling deep into the southern region of space, there is literally only one facility on Earth that can even reach it. The massive 70-meter Deep Space Network antenna located in Canberra, Australia. That single giant dish was the absolute only lifeline capable of beaming this hack out into the void.
So during that nail-biting 38-hour wait, the engineers basically just monitored temperatures, evaluated system responses, and hoped. They knew perfectly well that the absolute slightest miscalculation in this delicate balance could kill the spacecraft instantly. Altering those power routes could have caused temperatures to drop drastically, which would literally freeze the entire ship, or it could have caused its ancient memory systems to simply crash, silencing Voyager 2 forever. It was a terrifyingly narrow margin for success. But then, the signal came back. The result? Absolute success. Against all odds, this high-stakes gamble paid off beautifully. The engineers achieved the exact stability they needed, breathing at least another full year of life into the aging Explorer without having to turn off a single other science instrument.
Part 5. Humanity's Limitless Desire, the Untrodden Forest.
Honestly, seeing humans put this much immense effort into keeping a machine, one built for just 5 years, alive for nearly half a century, it really shows our limitless desire to just understand the universe. It's perfectly described as being like a tiny sensor sent into a thick, untrodden forest where no human has ever set foot. The space between the stars, it isn't just empty nothingness, it's actually filled with shifting particle densities and complex magnetic fields. And even as it runs out of its very last drops of power, this 1970s iron bird, literally running on vintage computer memory, continues to whisper secrets back to us from a dark, uncharted wilderness that modern technology still cannot physically reach.
One day soon, the very last drop of its power will be gone. Voyager 2 will eventually freeze, and it'll drift silently forever in the endless dark, making no sound at all as it floats through the stars. But before that happens, it leaves us with a truly profound question. Will we ever be able to measure the true value of what Voyager gave us before it went silent? It's something that is absolutely going to keep scientists and dreamers looking up at the night sky for generations to come. Thanks for joining me on this explainer, and I will catch you on the next one.